now. So like in class when I put up like a formula on there, like a general formula with like letters, is that's
So
what
I
that
have
is.
to have a formula to solve this.
Well, using that formula, you can solve any applied question. That's what it is.
It's cool. I didn't know they did practice questions.
Yeah,
Something called QMAT.
I don't even know what that is.
I just
I'm
looked up
still
calculus problem that it popped up.
I'm still learning like Google as we speak.
It says, what is the derivative of x plus 1 sin x?
Whatever that is. It is like what they're asking is for the slope of the curve. But aside from that, any questions from class? Yes? What you got? Wait, hold on. No. Go ahead.
Negative.
No, let me get him first because you got his hand up. What you got? The square root of 27,000, just like that. That's it.
It's very out.
30? Oh. Is it? 30 times 30 is 2,700, is 27,000?
It's like 30 squared inside, and then there's a very good outside.
Oh, you saying like 30 to the third power? Like that?
Like break 30. And then square thing right next to it.
Uh-huh.
Put a 30 inside. That's it.
Hmm. Interesting. Yeah.
30 squared,
Mhm.
900.
Mhm.
Times 30, 7,000.
Got you. Got you. So how I would have done this, right? Pretty much 27,000. I would have broke that up into two of them, right? I would have said, I'm trying to think. First off, I would divide this by 100, just straight up. I would have just took 100 off of this. So 100 times what 270 would give me that. Am I right about that? All right. So I'll just write the answer right there. Just looking at this. So 270 and 100, right? I'm not even going to continue with the 100 because we already know that that's 10, right? The 270 now is what I would be concerned with. So with 270, I would break this up into 27 times 10. All right. Just know that that's just going to be 10. For 27, this is what? Square root 9 and square root 3. Right? Put all of this together, right? This 10 right here is on the outside, right? And then I have let me see, a square root 9 times 10 times 3, something like that. And then the square root of 9 is what? 3, right? So this would be 10 times 3 square root whatever 10 times 3 is, right? So 30 square root 30. That's how I would have done it. So I would have pulled out what I know and then just keep going until I can't no more. Yeah. Any other questions?
Is there anyone to like check if you're right?
Yeah, when you submit, it tells you if you're right.
No, I mean like
Yeah.
math, like wise, like how do you check if you got the right?
Like you want to verify that
Yeah.
30 square root 30 is equal to that? Just doing a calculator. There's gonna be a decimal, right? And there'll be the two decimals will be the same. Go ahead, what you got? Okay. Of what? Say it again? Oh, 100? That's it? So it's just plus or minus 10. That's it. Yeah. In a computer?
Yeah.
So you do 10 comma negative 10. Yeah. Yeah. What you got?
Index of three.
The what?
Index of three.
Okay.
And then x to the 11th squared.
Like this?
Without the-
X to the 11 squared?
Oh, sorry, not squared. I meant like this. The square root. So you could take all that. It's just like that, and then it's
So inside the cube root is a square root?
no.
What?
When I said squared, I
Mhm.
just went. I just went.
The cube root. Okay. All right. Of what? So- Oh, just
X to the 11.
oh, x raised to the 11 power. Like that.
Yeah. And then simplify your answer as much as possible, and answer your answer as a fraction.
Okay. So rewrite this as a fraction. What does this become? X to what? Mm-mm. You did it yesterday. No, not 3 over 11. What is it? 11 over 3. Right? The power on the radicand is the numerator and the index is the denominator. That's it. Go ahead. Minus 7. So just to simplify it, right? So basically we need to get the same denominator in order to be able to do this subtraction, right? LCD over here is what? Uh-huh. Right. So all I have to do here is make the denominators the same, right? So this already has an x minus 2, so I'm going to multiply this by x minus 7. But what I do to the bottom, I do to the top. Over here for the x minus 7, I'm going to multiply this by x minus 2. What I do to the bottom, I got to do to the top. And then after that, just do the math like straightforward, right? X times x, this, you know? So I have what? X squared minus 7x minus 3x plus 21, right? And then plus, open parentheses, what's this? X squared minus 2x plus 5x minus 10, all divided by the x minus 2 and the x minus 7. It looks crazy, but it's not, right? Because it's addition, you could kind of just kill these parentheses right here and then just combine like terms. That's all it is. X squared plus x squared, what's that? 2x squared. That's done. Negative 7 plus, negative 7x plus negative 3x, it's negative 10x, plus negative 2x, that's negative 12x, plus positive 5, what is that? Negative 7. I mean, negative 3 plus negative 2 is negative 5, right? Plus positive 5, that's 0, right? So just negative 7. All right. So positive 21 plus negative 10 is what? 11, right? And then all of that is over the x minus 2 and the x minus 7. Now, not yet. After this, you have to see if you could factor this, right? Do a little AC method on it, see if you can. It's okay if you can't. If you can't, that's just the answer. But if you can, we have to simplify this even further, right? So let's try a little AC. So A times C is equal to 2 times 11, whoops, which is equal to what, 22? And then my B is equal to -7. So now I want two numbers that when I multiply them together will give me 22, but when I add them together, or in this case, subtract them, will give me -7. What are they? I'm thinking with you. So they have to
That's a -7.
and multiply to 22. Yeah. All right. So if it's not possible, then that's your answer. And that's it. You just type it in. All right, your question. Oh, wait, let me get him first because you've been waiting. Go ahead. That's it. All right. So what's the perfect square that goes into 24? Does 9 go in? Mhm. What's the next perfect square smaller than 9? No, smaller than 9. 4, okay. So does 4 go into 24? Okay.
But is asking answer A, C,
Now, when you find the final answer, then you'll see what it is, right? So it's square root 4 times 6, and the square root of 4 is 2, right? So your answer is -2 square root 6. And that's it. All right, go ahead.
So simplify the
Mm-hmm.
square root. So right in the simplify from A square root. And that's the forget.
So just square root 50?
Okay.
All right. So what's the largest perfect square that goes into 50? 25, right? So this becomes square root 25 times what? 2, right? And then the square root of 25 is, all right, so 5 square root 2. That's it. Just type it in. Mhm. Yeah, go ahead. Yeah. 2, that's the 2 answers. 5 square root 2.
I don't think.
No, we're doing that today, actually.
Oh,
Yeah, I
that's
got
a
you.
bunch.
Yeah. Yeah.
Get the right in square.
Mhm.
Part.
Yeah. Mhm.
25.
No, 5 square root 2.
Like this is your answer right here. You just plug it in to the boxes.
What?
No.
I'm so good.
That is 2.
Yeah,
5
2
and square root 2.
The square root 2.
Yeah. We could do that.
I don't remember how we.
I think we did that, but yeah, we could do that. The bottom
Has
was
to be applied to both, right?
yeah.
Oh, okay, and then subtract, right?
Yeah.
Oh, okay,
I'll show you.
like yesterday.
It says the bottom of the wrong.
So for this question, right? We're raising this to the -1/3 power. Right? So remember what happens when you raise it to a negative power? This goes into the denominator, right? So this becomes 1 over, right? Now we have 27/8 raised to the 1/3 power here, right? In the denominator. Apply that power onto everybody. So I have 1 over 27 to the 1/3 power over 8 to the 1/3 power. All right. And then 27 to the 1/3 power is what? Like, here's what I'm asking you. What's the cube root of 27? Right. And the cube root of 8? 2, right? So this is 1/3/2. And then now keep, change, flip, right? So I'm gonna keep the numerator, change the multiplication, flip the denominator, right? So final answer is just the 2/3. And that's it. Yeah. Yeah, let me see. Mhm. So what's C? No. So your answer is 5 square root 2. So what's C? So they asked you to enter in the answers like this, right? A square root C, right? This is your answer, 5 square root 2. So what's C? No, what's C? No, what's C? Okay. This is your answer, and this is what they want, right? So I'm asking you, like, I agree with you. A is 5, right? What's C? No, what's C?
5 square root 2.
No, what's C?
What's C?
Yeah,
Just
Just 2?
yeah.
You don't put scroll. I don't know for what, you have to put it, like, type it in. Scroll.
That
Yeah,
that's when it doesn't, yeah, that's when it doesn't have anything. Just the right, the full answer. Yeah. All right, go ahead. Wait, hold on 1 second. X squared over x plus 2. That's it. All right, so multiply by the denominator, x plus 2. And then what you do to one side, you do to the other, x plus 2, right? But now I have x squared is equal to, distribute this, 15x plus 30. Subtract these to the other side. I'm like doing it all in one step, because it's like real quick. Now you got x squared minus 15x minus 30 equals 0. And then you just solve it. All right, not too bad, right? So what two numbers multiply to negative 30 and add up to negative 15? 15, no, that's 15 and 15, I think is what, 225? No, they have to add up to negative 15 and multiply to negative 30. Well, 10 times 3 is 30, but 10 plus 3 is not 15. So one has to be positive, one has to be negative. I know that because the 30 is negative, and the only way to get a negative number through multiplication is if one number is positive, one number is negative. The bigger number is going to be negative. So what are they? Let's see, if we have 30, right? This is 10 and 3, 2 and 5. And that's 11. Guess it can't be done yet. Keyword there is yet. So we'll come back to this question another time.
Without the
You
method.
did this one? Really? Got you. There's another method that we're working on or we're building up to that'll be able to answer this. So we'll come back to this question. Any other questions? Mm-hmm. Cube root of what? Okay. So let's see, 1 plus 8 is 9, 9 and 9 is 18. So I know that this thing is divisible by 3. All right. So let's see, 189 divided by 3, what's that? That's 63. And 63 is 7 and 9, right?
Yeah.
And then 9 is 3 and 3. That's not so bad, right? So then now what you have cube root of negative, let's say 3 to the third power and 7, right? You already know that the cube root of the negative, the cube root of negative 3 to the third is going to cancel out. So negative 3 cube root 7. Not too bad. What you got? Mhm.
Negative 72.
72? I have no idea. Let's see.
I was thinking 9 and 8, then 9 will be 3, 3 and.
Is it 9 times 8 is 72? It is? Okay. Okay. That could work. 9 is 3 and 3. 8 is 2 and 4, right? And the 4 is 2 and 2. So you see where your triple is right there? It's that 2. So this becomes what? Cube root of negative 2 to the third power times 3 to the second, right? And then, you know, cube root of negative 2 cubed is going to come out. So this is negative. Wow. Really? There we go. So then this will be negative 2, right? Cube root of 3 squared or negative 2 cube root of 9. That's it. Go ahead. 48 squared?
Maybe 2 grams.
Like that? Like that? Okay. No. We're gonna do that today. Yeah. I mean, but if that's your way of saying you're ready to get on with the lesson, I could do that. All right. Yeah. All right, what's up? So do the same thing. You got 28, right? Just chop it in 2. Right? So this is 2 times what, 14? And then chop that in 2. Right? That's 7 times 2. Right? So this becomes what? Square root of 2 to the second times 7. Right? And then the square root of 2 to the second, you already know that's going to cancel out. So this becomes what? Negative 2 square root 7. That's it. The easier way would be to know that 4 times 7 is 28, but if you can't, think it through like this. You know, I don't know my timetables all the time, so I have to do this kind of stuff. So, all right, let's jump into the lesson. Mhm. Before we do that, let's do a little blast from the past, something real simple. Help me out, how I do this? And what do I do?
You divide by.
Not divide, distribute the negative, right? Distribute this over here. So I have what now? 3x squared plus 9x minus 5 minus x squared. A negative times a negative is a positive plus 2x. Negative times a positive is a negative minus 3. And what do I do after that? Combine like terms. So what do I get? No. Try again. 2x squared, very good. All right. What else? Plus 11x, right? 9x plus 2x. 11x minus 8. Very good. And we're done. That's it. That's not bad. That's not bad. All right, how I do this again? Foil it, right? So first, outer, inner, last, right? So what's the answer? 8. 2a, very good. Plus 4a, very good. Minus a what? Squared, right? Very good. Then after that, combine like terms. So what do I have? So I have 8, right? And then what's the middle? Okay, plus 2a minus a squared, all right? I'll take it. I mean, yeah, it's technically it should be negative a squared plus 2a plus 8. Technically, that's the way it is, but if you gave me the other one, I would give you credit for that. That's fine. Yeah. Go ahead. All right. So, same question, a little bit different. How I do this? Okay, write it 2 times. All right, so 9 minus 5y and 9 minus 5y. Okay. And FOIL it. All right, cool. So what's the answer? So 81. That's 45y. Very good. What's next? 45y. Good. Plus 1. 25y squared. Very good. Oops. It's 45. You're right. My fault. And then what do I do after that? So what do I have? Say it again. 0. No. Negative 90. Very good. All right, so remember this, right? Spoiling. All right, so let's look at what we're getting into today, which you guys probably saw from the homework. Right? So we're gonna add and subtract radical expressions. Yay. So adding radical expressions with the same index and the same radicand is just like adding like terms. So we call radicals with the same index and the same radicand like radicals to remind us they work the same as like terms. All right. So big shock, we all know how to do this already. All right. So like radicals, all right? Like radicals are radical expressions with the same index number and the same radicand, right? Same index number, same radicand. All right, let's talk a little bit more about it. All right, so we add and subtract like radicals in the same way we add and subtract like terms. We know that 3x plus 8x is 11x, right? Similarly, we add 3 times the square root of x plus 8 times the square root of x, and the result is 11 square root of x. Think about adding like terms with variables as you do the next few examples. When you have like radicals, you just add or subtract the coefficients. When the radicals are not alike, you cannot combine the terms. All right? You just leave them the way they are. You cannot combine them if the radicands or the index is different. All right? So let's take a look. Let's take a look. So I want to simplify these, right? I'm gonna start off with A. So for A, all right, I have 2 square root 2 minus 7 square root 2. Now I notice, right, the radicals are the same, right? They have the same index, they have the same radicand, right? So I'm just looking at the number in front, the coefficient, right? 2 minus 7 is what? -5, right? So this is -5 square root 2. That's the answer. I'm done. That's all this is. All right. Let me change my color real quick. All right. I'm going to do B. So I have the cube root of y plus 4 cube root of y. I notice that the radicals are the same. They have the same index, 3 and 3. They have the same radicand, y and y, right? So I'm just looking at the, right? Right. So I'm just looking at the number in front. So 1 plus 4, this is 5 cube root of y, huh? Wow. My fault. This thing was hidden. My fault. All right. So 5 plus 4, 9 cube root of y. There we go. Right? No. It's simple. Promise you, it's gonna be a simple one. All right, let me get C real quick. So for C, I have 7 4th root of x minus 2 4th root of y, right? So what's the answer? No, you can't combine it, right? So that's the answer. I'm done. All right. Right. The radicands are different. So when they're different, they can't be combined. Right. So just leave it alone. Right. Mm-hmm. So any questions on this? Does this make sense? All right. Just so I'm clear, what are the answers? That's an answer. That's an answer. This is an answer. All right. Any questions? We good? All right, you guys try. That's a part of the answer. You could probably finish it in class.
Probably, yeah, it's not good. But,
Why not just refresh it? You'll see it.
no, I mean, like 3 more.
Oh, yeah. Yeah. That's even easier than this.
Hopefully.
And by the way, when you guys are doing the homework and all that, right? I really don't care how many times y'all try the problem until you get it right. So go crazy with it if you want. Right? All I care about is that you get 100 on the homework. Right? All right, let's try this out. So, hold on, I need a pen. All right, let's try this out. So for A, right? What's the answer for A? -1 what? Very good. All right. Let me change my color real quick. What's the answer for B? Excuse me. 11 cube root of X. Very good. Let me change my color. What's the answer for C? Good. So 3, 4th root of X minus 5, 4th root of Y. Go ahead. How do you do it? Oh, like into the web work. So if I was gonna enter this, it would be yeah. No, not SQRT. No. It's not like that. So for web work, right? This one is for C. So this would be 3, and then let me think about it. I would do open parentheses, X raised, open parentheses to 1 divided by 4, close parentheses, minus 5, open parentheses, Y raised, open parentheses to 1 divided by 4, close parentheses, close parentheses. That's how I would enter it. You can either type it out like that, or there's like on the side of it, you can like click it. And then, yeah. Mhm. Like the 4th root and stuff. It should be. I have to take a look at it, but it should be. You know, to put it in there. Got you. Before we leave, let me take a look. Let's see. All right. That's for that one. All right, so for radicals to be like, they must have the same index and radicand. When the radicands contain more than one variable, as long as all the variables and their exponents are identical, the radicands are the same. All right. So let's take a look at what I'm talking about. This is the same for addition and subtraction, by the way. So let's look at A. So for A, I have 2 square root of 5n minus 6 square root of 5n plus 4 square root of 5n, right? This is not bad at all. 2 square root 5n minus 6 square root 5n plus 4 square root 5n, right? Just put this up here. Now, I notice they all have the same index. They all have the same radicand. So I'm just dealing with the numbers in front. So 2 minus 6, what's that? -4, right? And then -4 plus 4? Very good. So that's my answer right there. That's simple. Mhm. Mhm. Well, anything times 0 is 0, so yeah. Mhm. Mhm. All right, so look, they have the same radicand, right? Huh? I got you. No, that's coming up next. I got you. So they have the same radicand, right? And the same index. So all I'm doing is I'm dealing with the coefficient, the number that's in front, right? So this becomes what? 2 minus 6 plus 4, right? And then the square root of 5n. And then 2 minus 6 plus 4 is just 0. So 0 square root of 5n. And you know anything times 0 is 0, right? So then that's just the answer. And that's it. Mhm. Let's take a look at B though. B looks like it might be crazy. So for B, right? I have the fourth root of 3xy plus 5 times the fourth root of 3xy minus 4 times the fourth root of 3xy, right? Now I notice that they all have the same index. They have the same radicand, right? So I'm just dealing with the coefficient, the numbers that are in front, right? So what does this become? This becomes 1 plus 5 minus 4 times the fourth root of 3xy. Now, 1 plus 5 is 6, and 6 minus 4, what's that, 2? So my answer is 2, fourth root, 3xy. And that's it. All right. This makes sense? A little bit? All right. So you see how there's no number in front over here in the beginning? That's 1. Like there's like an imaginary 1 there.
Over five.
Right.
Okay,
Yeah.
it's kind of like the variable on this.
Yeah. All right, you guys try. Mm-hmm. Mhm.
say, and then first Ukrainian president, and it's President Putin. Introduced this is President Putin.
Nice. I heard that Zelensky was gonna be there at the summit.
Yeah, that's it. That's it. That's
Yeah,
insane.
I mean, it could happen. I mean, like they neighbors, like, you know. It's like they both are on like Fordham Road, except one of them is like up here and the other one's like that. All right, let's take a look at this, right? So for A, right? I have square root 7x minus 7 square root 7x plus 4 square root 7x, right? I notice that they have the same index and the same radicand. So I'm just dealing with the coefficient of numbers in front. So what do I have? I have 1 minus 7 plus 4 times the square root of 7x. And then 1 minus 7 plus 4, what's that? Negative 2. And then square root 7x. I think so. It's negative 6 and negative 6 plus 4, negative 2. Well, negative 6 plus 4. Mhm. Like you owe me $6 and you give me 4. Yeah. 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 I can't remember where I learned negative numbers. I feel like it was in high school. Like that was a trip, you know? Like I could owe somebody money? Like what you mean? Like yeah.
Like,
Yo.
say like 1,000 on his shit.
Damn. Yo. No, but you know what could happen though? Sometimes like they don't take out enough taxes and you have to pay back more. Or sometimes they take out too much, then you get the refund.
Yeah,
So-
you gotta put in that request, right?
yeah.
That's great. I heard they have like the exact number, but they just want to do.
Which I don't get why. Like you have our socials, just do it for us and let us verify it. You know? It's all right though, because as soon as AI gets smart enough, right? You get no like tax people, they gonna die. Watch. No offense. Nah, there'll always be a need for somebody with tax knowledge though, because you have tax laws that are constantly changing. You know, like Biden has his idea, Trump got his ideas of what he wants to do, you know? And depending on who comes into power, like somebody gotta learn that idea and implement it. So it's like ever changing. So okay, for B now, right? I got 4, 4th root of 5xy plus 2, 4th root of 5xy minus 7, 4th root of 5xy. I notice they have the same index and they have the same radicand, right? So I'm just dealing with the numbers that are in front. So what do I have? Right.
You have to do that.
You could just write it. I'm just doing that so that you can see where it's coming from. So yeah, negative 1, 4th root of 5xy. And yeah, you can also do that. You can just say negative 4th root of 5xy. That's completely correct as well, without them doing the 1. No, that's correct. Yeah, that's correct. Yeah, yeah. Like I would accept both answers though. All right, so remember, right, that we always simplify radicals by removing the largest factor from the radicand that is a power of the index. Once each radical is simplified, we can then decide if they are like radicals, all right? So for example, now this is gonna look a little bit more like last night's homework, right? Whoops, okay. So for A, all right, I have the square root of 20 plus 3 times the square root of 5. All right. I can simplify the square root of 20, right? And that simplifies down into what? 5 times times 4, right? So this will become like square root, let's say 4 times 5 plus the same 3 square root 5. And then the square root of 4 is 2, right? So this is 2 square root 5 plus 3 square root 5. And then 2 plus 3 is 5, right? So final answer, 5 square root 5. Questions on that? So all I'm saying is that you might have two radicals where they have the same index, but the radicand might look different. However, you might be able to break it down and make it the same. And if you can do that, break it down, make it the same, combine the like terms, right? And then if you can't break it down, then you already know that that's just the final answer, right?
So, might be the fraction, so
Mm-hmm.
better get the same.
Exactly, right? So now look, I have the cube root of 24 minus the cube root of 375, right? So is there a perfect cube that goes into 24? Not 4, a little bit bigger than that. 8, here we go. So we have cube root of 8 times 3 minus, is there a perfect cube that goes into 375? Not 25, that's not a cube. 5 and 15, no.
Oh, wait,
Mm-hmm. So I'm thinking of more like 125 times 3, right? And then cube root of 8 is what? 2, right? So this is 2 cube root of 3 minus cube root of 125 is, say it again. I feel like somebody said it, 5, and then cube root of 3. Now I notice they have the same index, same radicand, so I can just deal with the coefficients. So 2 minus 5, what's that? Close. -3 cube root of 3. And that's it. That's the answer. Questions? Go ahead. Yeah, it's the same old, same old. Even if you didn't know that, right? Do the tree. The tree won't lie to you, right? So if you had 375, right? It ends in 5, so that should be like the first thing you're thinking, like, oh, this is probably divisible by 5, right? So then you just do 5 here, and then 5 times what is 375? What number is that? 75? All right, so then we have 75 here. And then just keep breaking it down, right? 75 is what? 25 times 3? And then this is 5 and 5, right? So you see the cube right there, there's 3 5s. Yeah.
Well, that's maybe just add whatever the most common,
Count them. Yeah.
and then
And then just pull it out. Yeah. That's how I do it. Go ahead. The cube root? Yeah, it's the perfect number that goes out. Yeah. So yeah, that's my way of doing it. Matter of fact, I'm not even gonna hold you. If I'm looking at C, right? I have no idea what that second one is. 4 through to 243. All I'm thinking about is doing that tree for that. You know?
Build it.
Yeah. By the time we're done, we're gonna have a whole forest. So I got 1/2, 4 through to 48, minus 2/3, 4 through to 243. Right? Now, is there a perfect fourth that goes into 48? Like a perfect fourth number or whatever, something to the fourth power that goes into 48. Let's see. We know that 48 is what, 4 and 12? And then 4 is 2 and 2. And then 12 is what? 6 and 2, okay. And then 6 is 2 and 3, right? So I have 1, 2, 3, 4 2s, right? So I know that I could rewrite this as the fourth root of 2 to the 4 power times 3, right? And then when I go a step further to what you call it, simplify this, the fourth root of 2 to the 4 is just times 2. And then we have the fourth root of 3 that's left over. You got lost? Where'd I lose you? So you know how to break down to 48, right? Like I'm just looking for two numbers that multiply to 48. Right? And then I just keep breaking it down until I get all of its basic prime numbers. Once I have the prime numbers, I just count how many of them there are, right? So there's 1, 2, 3, 4 2s, right? So I have 2 to the 4th power right here. And then I have 1 3, right? So this is the 1 3 that's right here. Now, the 2 to the 4th root of 2 to the 4th power is just 2. Right? You remember seeing that on your homework? If I have like a 4th root and then I have 2 to like the 4th power, for example, these cancel out, leaving back just 2. Like that's what's happening here. Half? Oh no, that was in the question. Yeah, half was in the original question. Yeah. Yeah. Yeah, I didn't make that part up. And then now, the 243. The only thing I could tell you that I know that 2 plus 4 is 6, and 6 plus 3 is 9, right? 9 is divisible by 3, so this big number, 243, is divisible by 3. That's all I know. So when I divide that by 3, what do I get?
Oh,
81, right? 243 by 3, right? So I get 81. Now, 81 we know is just 9 and 9. And you already know 9 is 3 and 3. And 9 is 3 and 3. So let's look. I have 1, 2, 3, 4, 5 3s, right? 5 3s. Right, hold on. Do 2 over 3 here. So I have 5 3s, right? I need only 4 of them to cancel out with the 4th root. So I'm gonna have 3 to the 4 times 3 to the 1. Just like that, right? And then the 4th root and 3 to the 4th will cancel out, leaving back just 3 on the outside. And then I have 4th root of 3 to the 1, just like that. After that, simplify it, right? Let's multiply these fractions together. 1/2 times 2, what's that? What's 1/2 times 2/1? 2/2, and 2/2 becomes 1, right? Exactly, right? Right, so this is just 1/4 root of 3, for example. Now I have 2/3, and bring on the minus sign. 2/3 times 3/1, what's that? Two over three times 3/1. What does that become? Yeah, and that reduces to what? I have. Mhm. What is it? 2/1, right? So I'm gonna just call that 2, right? You could also say that 3 goes into 3 once and 3 goes into 3 once if you want to make that simple. And I still have the 4th root of 3. Now look, they have the same radicand, the same index number, right? So I'm just dealing with the coefficients. 1 minus 2 is what? -1, right? So final answer, negative 4th root of 3. And then that's it for C.
So whenever you guys like a fraction, you just cancel out.
Just multiply them. Yeah. Oh yeah. If it's the same numbers like diagonally or on top, you can cancel them out.
How do you multiply that?
Mhm.
So when I do it, I get a decimal.
Really?
Yeah.
When you did 2/3 times 3/1?
No. When I get like a fraction and it says times it.
Like what part? Like tell me.
Times, when you see that 1/2 on the middle part,
Uh-huh.
you're not supposed to do it there?
Like you mean 1/2 times 2?
Yeah,
You shouldn't get a decimal for that.
I don't know, I did it before. Yeah, I got one.
Yeah. 0.5 times 2. That's one. All right, not bad, not bad. All right, try it out. The other one is better.
So the 10,
The black calculator.
so it's.
Um,
Wait, what's the fish?
I mean, it don't have as much on it. Yeah, just come to it and I'll show you.
No, use it for the.
I just don't have time to go over that right now.
Use like how, like, to do the prompts, like. That tree.
The tree thing is fire, yo.
I don't know how to do that, like, it's taking that long to, like, I don't know how you got 81, I would never know. Is it 'cause of
So-
43?
Honestly, I don't care how big the number is, just try and pull out a prime number, like divided by a prime number. So prime numbers are numbers that are divisible by one in itself only, right? Basic numbers. So we're talking about like 1, 2, well, no, not 1, like 2, 3, 5, 7. What's after 7? I can't even think. No, not 9. 11. Yeah. Yeah, like it can only be divisible by one in itself, 13, 17, you know? So whatever number is there, just think to divide by one of those numbers. And then that's
Then you
it.
get the second one.
Yeah, and then whatever that second number is, try to pull out another one until you get to a final prime number. And then that's it.
So I was going over this stuff with my coworker, who's saying like, there's like, when you're doing the square root of one big number, there's multiple, not multiple answers, but you get the same answer, like there's more steps.
True, yeah. So what he's saying is that you could, instead of picking out like the biggest perfect whatever, right? If there's a smaller one that you see, like how you saw me do the 27,000, right? You could pull that out first and then just keep breaking it down until it's like simple and get the final answer.
That always work, or sometimes
Always.
you gotta have,
Always, it always works. Like I said, sometimes I look at these numbers and I don't know how to break them down. So I have to do the trees and stuff, They always work.
okay. You use the calculator though, for the 243, you just knew.
No, I didn't know. So what I did, right?
Divided by
You see how it's 243. I added all the digits together. So 2 plus 4 plus 3, right? So 2 plus 4 is 6, 6 plus 3 is 9, right? So I know that 3 can divide 9, right? So because I knew that, then that means that 3 could divide 243. So when you add up all the numbers, right, that whatever number
That works for
that is, it works all the time. If you add up like if you have some big number, right, and you add up all of the digits, right, and the sum of all of the digits is a number that's divisible by 3, then that big number is divisible by 3.
How would that work for 250 there? 25, that's it, or 2 plus 5 is 7.
25 could work, right? 25 times what?
5, 7.
Times 10, right? Then you just break down to 25 and break down to 10.
How would you do it with your method? So 5 plus 7.
Oh no, that wouldn't work. So for the fives now, right? If it ends in 0 or it ends in 5, it's probably divisible by 5. Right? So it's like that's another trick. For the twos, you already know if it's an even number, it's probably divisible by 2. So if it like ends in like a 6, an 8, whatever, it's probably divisible by 2.
That's cool. Okay, I just tried 24, you just divide it by 6.
Yeah.
And it's 4.
That's it. So let's try this out, right? For A, what do we get for A as an answer? 9. Very good. Questions on that? Everybody got that one? Oh, so you have square root 18, right? Plus 6 square root 2. And then what's the largest perfect square that goes in 18? 9, right? So this is square root 9 times 2 plus 6 square root 2. And then the square root of 9 is 3, right? So 3 square root 2 plus 6 square root 2. All right, they got the same radical, same radicand, so we're just gonna add the coefficient. So 3 plus 6, that's the 9 square root 2. And that's it. How about B? Is what? Like the final answer? But there's no negative here, and 6 is part of it. So like it had to be bigger than 6. All right. So for B, let's try this out, right? I have cube root of 16 minus 2, cube root of 250. Cube root of 16, I feel like is like cube root of 8 times 2, something like that. Not 4. And then minus 2 cube root of, what's this?
Oh, yeah, you're right.
125 times 2. And then cube root of 8 is what? 2, right? So 2 cube root of 2 minus 2 times 5 cube root of 2, something like that. And we just do the math on that. 2 cube root of 2 minus 10 cube root of 2. I noticed that they have the same radicand, same index. Just dealing with the numbers out front. 2 minus 10 is what? Negative 8, right? So negative 8 cube root of 2. Questions on that? We good? B.
How's the cube root 8 times 2?
So the perfect cube that goes into 16 is 8. Right?
8 times.
And 8 times 2 is 16, right?
I thought it was just like a number times, so 3 times, so 8 times.
Well, 2 times itself 3 times is 8. Yeah, like 2 times 2, 4, 4 times 2, 8. So 2 to the third power is 8.
Okay, so then that's the cube.
Mm-hmm. Right? There's a 6. Oh, whoops. My fault. 6, 6, 6. All right, so what's that? 12? Erase that. Call that 12. 12 minus 10, that's 2. Thank you. Good catch. Good catch. All right, so for C, right? I have 2 over 3 cube root 81 minus half cube roots 24. All right. What's the largest perfect cube that goes into 81? 9? I think it's 3 times what? 99 is 81. Yeah. Right. So 2 over 3. It's going to be cube root 27 times 3 minus 1/2. And then largest perfect cube that goes into 24. Said that earlier. What is it? Yeah. Is it 6? 8 and 3, that's it. Right. 24, yeah. Yeah. And then cube root of 27, we know is just 3. Cube root of 3 minus 1/2. Cube root of 8 is what? 2/1 times cube root of 3. Do a little multiplication on these.
Question.
Mhm.
So, 6 is not.
6 is, it's not a perfect cube, no. No. And that would be what, 6 times 4, I think? Like, that's not perfect. 4 is not perfect either. Yeah. But 8 is, though. Like, 8 is a perfect cube. And then 2 and 2, this is 1 and 1, so 1's cube root of 3. All right, so 2 cube root of 3 minus 1 cube root of 3 is what? 1 cube root of 3, right? And that's my answer. All right. Let's take a look at another one. All right, I got you. Got you. Hold on. Let's take a look at this one. So we have 9 square root 50m squared minus 6 square root 48m squared, right? So what I want to do, I want to simplify the radicands first, right? So this is going to be what? 9 times square root, what, 25 m squared times 2 minus 6 square root, what's this? 16 m squared times, what's that, 3? Am I right about that? 16 times 3 is 48? Or is it 4? Sixteen times 3. It's 3? 48? All right, good. All right. Simplify this down. So square root of 25 is what? 5. Square root of m squared is just m, right? And then that leaves what? Square root of 2 minus 6 times square root of 16 is 4. Square root of m squared is just m. And then I have what? Square root of 3. Let's do the math on this. 9 times 5, what's that? 45m. Square root 2 minus, what's this? 6 and 6 is 12, 24. M. Square root of 3. Now notice they have different radicands and I can't simplify it any further. So this whole thing is my answer. All right? The 25? So 25 times 2 is 50, right? Yeah, so that's, I'm breaking down to 50. Right. I wanted the largest perfect square. Yeah. Then that's that. Let's look at B. I have the cube root of 54 n to the fifth power minus the cube root of 16 n to the fifth power. Right? Largest perfect cube that goes into 54, what's that? Largest perfect cube that goes into 54. 9 and 6, no. I'm thinking like 27 maybe. Something like that.
Yeah.
Yeah. So 27, right? N to the third power times 2 n to the second. Why did I split the n to the fifth power, right? Because I want a term, right? That's divisible by the index, right? N to the third power is divisible by the index, divisible by 3. Now I'm looking at the other one. This should be what? Cube root of 8. All right, 2 is in there too, right? 2. It's gonna be n to the third times 2 n to the second, right? Simplify this down. This becomes what? Cube root of 27 is 3, right? The cube root and the n to the third will cancel out, leaving back just n. And then I have the cube root of 2n squared minus over here, cube root of 8, we know is 2. Cube root of n cubed is just the n. And then that leaves back what? The cube root of 2n squared. They have the same radicand and the same index. 3 minus 2 is what? 1, right? So this is going to be n cube root 2n to the second, right? And then that's that. I don't think anything on your homework is that complicated. That was just for fun. With that being said, let's look at the second part of the homework. Before we do that though, right? I just want to do a little refresher real quick. So you guys remember the product property of roots, right? So for any real numbers, the nth root of a and the nth root of b, and for any integer, n greater than or equal to 2, the nth root of a times b is equal to the nth root of a times the nth root of b, and the nth root of a times the nth root of b is equal to the nth root of a times b, right? Just wanted to refresh our memory a little bit on that. That being said, here's what we're getting into. All right. So when we multiply two radicals, they must have the same index. Y'all heard me? We multiply two radicals, they must have the same index. So once we multiply the radicals, then we look for factors that are a power of the index and simplify the radical whenever possible. So multiplying radicals with coefficients is much like multiplying variables with coefficients, right? So to multiply 4x times 3y, right? We multiply their coefficients together and the variables, and we get what? 12xy. Keep this in mind as you do these examples, all right? So let's take a look. So for A, right? I have 6 square root of 2 times 3 square root of 10, right? Here's the trick. Multiply numbers with numbers, radicands with radicands. That's the hint, right? So 6 times 3, what's that? 18, right? I forgot how to write 8. Let me try that again, okay? And then radical 2 times radical 10 is going to be radical 20. Very good. But I'm not done though, right? Because 20 could get simplified, right? So this is going to simplify down into what? 18 radical 4 times 5, right? Because 4 is the perfect square. That goes into 20. And then the square root of 4 is 2, right? So this is 18. I keep forgetting how to write 8. Keep forgetting how to write 8. Let's try that again. Good. So 18 times 2. And then the radical 5. And 18 times 2, what's that? 36, I think. So 36 radical 5. And that's it.
Where did you come from?
Square root of 4.
Oh. Well,
Yeah, 18.
No, but 18 is not under the radical. It's outside.
okay.
Yeah. So when we multiply radicals, right? Numbers with numbers, radicands with radicands, if they have the same index. All right. So let's take a look at B. All right. So I have -5 cube root of 4 times -4 cube root of 6, right? Numbers with numbers, radicands with radicands. They both have the same index, right? So -5 times -4 is what? 20, very good. And cube root of 4 times cube root of 6 is what? 4 times 6, which is what? 24, right? Huh? So cube root of 4 times cube root of 6 is what? Right? So cube root of 24.
Oh, no.
Oh, positive. So radicands, we just multiply them together, right? So cube root of 4 times cube root of 6 is cube root of 24. But cube root of 24 can get broken down, right? We could break that down into what? 20 cube root of, what's this? 8 times 3, right? And then the cube root of 8 is what? 2, right? So this becomes 20 times 2 cube root of 3, right? And then 20 times 2, what's that? 40 cube root of 3. And that's that. Hmm? The 2 on the outside? The cube root of 8 is 2.
I feel like this is more simple than the addition of five.
Hmm? Hmm? Because it's simplifying, right? Like imagine 8 is 2 to the third power. So that third power and the cube root are canceling out. So it's just a whole 2 on the outside. Yes, that's why. Then you just multiply them together at the special. And that's it. You guys try. All right, let's take a look. For A, what you got? Six what? Okay, square root of 60, good. Can 60 get broken down? Into what? 30 times 2, no. 4 and 15, right? Yeah. And then the square root of 4 is what? 2, right? So this is 6 times 2, square root 15, right? And then 6 times 2 is what? So 12, square root 15. That's it. How about B? All right, numbers with numbers, radicands with radicands, right? So what do we have? -6, cube root of 108, okay? And then what's the perfect cube that goes into 108? Okay. So cube root of 36 times 3, and the cube root of 36 is what? Oh. Mhm. What's the cube root of 36 or whatever? No. It's 12. 12 and 4.
Oh, 36.
12 is a perfect cube. Mhm. So wait, 18 times 6 is 108? Okay. 9 is not perfect, no. So if you don't know, just do the tree. The tree will never fail you, right? This is what, 54 and 2? This is 2 and what's that? 25, 26, 27. And then this is what? 9 and 3, and then 3 and 3. So we got 3 threes, right? So this is 3 to the third times 2 to the second, 3 to the third, and the cube will cancel out, leaving back -6 times 3. And we have what? The cube root of 2 to the second. So this is what? -18 cube root of 4. And that's my answer. Yeah, 2 times -3. Yeah. Yeah. Questions on this? Oh,
The notice that the number that you multiply to the. Why do you always take something out of the? Or
because that's a perfect like index number. Right?
just keep it there?
Nah, it has to come out. It's canceling out with the index, so it's just becoming a whole number on the
Oh,
outside.
the threes.
Yeah. Like this little 3 right here is canceling out with the cube root. You know, and then it's coming out as a whole 3 by itself. And then now we can combine with the 6s on the outside. Go ahead. Mhm. Yeah. So that's canceling out, leaving back the whole 3 that's in parentheses right here. And then now you can multiply them, -6 times 3, -18. And then, right, which is like 4, so. Yeah, that's my secret technique on how I do this. You guys try. All right, let's take a look real quick, all right? So for A, what you guys got? 27 square root 2. I like that. Yeah. Everybody got that, or anybody got a question? You got 81 square root 2? All right, let's take a look. 3 times 3, right? 3 times 3 we know is 9. And then square root of 3 times square root of 6 is square root 18. And then you know that square root 18 is going to get broken down into square root 9 times 2. And then the square root of 9, we know is 3, right? So this is 9 times 3, square root 2. So 27 square root 2. Not bad, not bad. How about B? What we got for B? All right. So -4 times 3, -12. And then I have the cube root of, what's 9 times 6? 54, okay. And then largest perfect square that goes, perfect cube, excuse me, that goes into 54 is what? 18? Is it? 18 is a perfect cube?
Oh,
I was thinking more like 27 times 2, no? And then the cube root of 27 is 3, right? And then cube root of 2. And then 3 times 12, negative 36, cube root of 2. Hmm. 9 and 3 for the perfect cube. Hmm. Like were you using the tree? Okay. So when you use the tree, yeah, keep going. So you get all the prime numbers. Right? So you should have like 3 to the third power and 2 to the first power when it's all done.
How do you get three? Where do you go?
The cube root of 27.
Oh, okay.
Yeah. Right, so then that one of those threes goes out to multiply times a 12 and then negative 36. Not bad. Even though it might seem a little tricky right now, like when you guys practice this a little bit, you'll get it. Not to mention that you have the calculator, right?
I need to buy one.
You buy one?
Uh,
Get the one from Staples, like a little black one, $20. That's all you need. Yeah. 36X Pro.
You was talking about
TI 36X Pro. That's
CI.
all. Yeah, that's all you need. $20 and that's it.
30X.
36X Pro. Oh, color edition one is better, but that's more money. I mean, if you have the money, get it, you know? Yeah.
makes
It does way more stuff. It can graph and all of that, you know? I don't have time to show you that, but
the linear
I'll tell you
equation.
to do that. You do all of that. Yeah. But it's mad money though. You know, so I don't want to break your pocket either.
But how much is it,
Like 180 or something. Yeah. We see that other one, $20. Yeah. Inflation used to be less. So all right, let's talk about something else that is on your homework as well. Now that we know how to multiply these things, right? Uh-huh. Good. All right, cool. All right, so we want to use polynomial multiplication to multiply radical expressions. So in the next few examples, we will use the distributive property to multiply expressions with radicals. First, we will distribute and then simplify the radicals when possible. All right? This is not bad. Kind of rushing for time a little bit, so I'm just gonna stick to like doing the A's real quick. Just 'cause I want you guys to be able to see this done at least once. So for A, I have the square root of 6 times the square root of 2 plus the square root of 18, right? What am I gonna do here? Distribute. That's it. Distribute it. Multiply. That's all we're doing, right? So square root 6 times square root 2, that becomes what? Square root 12 plus Square root 6 times square root of 18 is what? Square root 108, right? And then now we can simplify these radicals, right? So square root of 12, this is what? Square root 4 times 3, right? And then square root of 108 is what? What's a perfect square that goes into that? You don't got to do it all at once. You could give me something small like square root 9 times 12, right? And then we could just take it from there. So this becomes what? 2 square root 3 plus 3 square root 12. And then just break down the 12 again. Ain't nothing wrong with that, right? So this becomes 2 square root 3 plus 3 times square root 4 times 3. And then the square root of 4 we know is 2. So 2 square root 3 plus 3 times 2 square root 3. I'm making it a lot more than what it is. And then 3 times 2 is 6, right? So this is 2 square root 3 plus 6 square root 3. They have the same radicand, the same index. Add these up. This is 8 square root 3. Final answer. All right. So it's okay if you don't see the largest perfect square that goes into it, right? You can break it down with something that you can see and then just go step by step until it can't get broken down anymore. All right. That's legal. That's fine. All right, real quick, I'm looking at the time, so that's why I'm going a little fast right now. Just one more thing to show you. So when we worked with polynomials, we multiplied binomials by binomials. Remember, this gave us 4 products before we combined any like terms. To be sure to get all 4 products, we organize our work usually by the FOIL method, right? So this is where I'm going with this. I just want to pick like one really good example and then we can wrap it at that. 1 second. Nope, that's too easy. That's too easy. Yo, these questions be too easy, yo. Okay. All right, I'm gonna just pick this one. That's a little too easy. Hold on. Yeah, I can't win. They all easy. Yeah, that means your homework is easy. All right, so here's this one example real quick. Again, because of time, I'm just gonna stick to A. All right. So I have 3 minus 2 square root 7 times 4 minus 2 square root 7, right? So what you're gonna do here is FOIL it the same way that we did before. First, outer, inner, last, right? So now with the first one, 3 times 4, what's that? 12, right? And then 3 times negative 2 square root 7 is what? Negative 6 what? Nope. Negative 6 square root 7, that's it. All right? Negative 2 square root 7 times 4 is what? Negative 8 what? Square root 7, very good. Now, it's complicated. Negative 2 square root 7 times negative 2 square root 7 is what? Okay, positive 4 square root what? No, square root what? 49, right? Remember, numbers with numbers, radicands with radicands, right? All right, awesome. Let's combine like terms here, right? And simplify this and all that good stuff, right? So I still have my 12. I see I have a radical 7 and a radical 7. So you already know, right? Same index, same radicand, coefficients. -6 minus 8, what's that? 13 or 14? -14 square root 7 plus 4 square root 49. But hold up. Square root of 49 is what again? 7, right? So this becomes what? 12 minus 14 square root 7 plus 4 times 7. Help me out. What's 4 times 7 again? 28, right? So I have 12 minus 14 square root 7 plus 28. Let's combine like terms real quick, right? 12 plus 28, what's that? 16? 12 plus 28?
I don't like 6.
40, right? So this is 40 minus 14 square root 7. This is my final answer.
So minus.
Yeah. Oh, but the minus is on the 14. That's why. Got you. So long story short, right? Y'all know how to multiply these things. When you see a binomial, just FOIL it the same way that we did before. Sorry about that. Yeah, just FOIL it the same way that we did before. Right? And whenever you're multiplying, what you call it? Radicals, right? The coefficient numbers with the coefficient numbers and the radicands with the radicands. That's it. But make sure that they have the same index. All right? Make sure they have the same index. And that's it. Y'all know how to do your homework. Try it out. Tutoring is online tomorrow and Saturday, 12 to 6. If anybody wants to come, just make the appointment online so that they can email you the link for tutoring. And then you just go. You can knock out your homework in tutoring, nothing wrong with that. All right. You can ask them how to use a calculator too. It's on Zoom, yeah. All of that is on Zoom. Yeah. That's for Friday and Saturday, 12 to 6. All online, yeah. Monday, back to in person, right? Right.
I'm trying to contact.
All right, cool. Yeah. RC, man. Yes. Yeah. I mean, if you want, you can make an appointment with somebody that way, like they guarantee free for you. Yeah, anybody. But you have your choice of everybody, because everybody does this class. So anybody. Yeah. But you can also just walk into. That's fine as well. Yeah. Right? Yeah. The $20 one or the $2,000 one? So the graphing one, that's TI 84 color edition.
84?
Yeah, that's the graphing one. But it's mad money, you know? The cheaper one is a TI 3684. That one.
This one?
Yeah. But depending on your major, like remind what you're doing again. Okay. Yeah. Oh yeah. You should get that. Yeah.
That way it's all the class.
Yeah. They even make it now with Python. See that? Yeah. They even make it now with Python, so it helps with coding and all that. Yeah.
I gotta review.
Yeah.
The one that I missed,
Yeah.
I'm kind of like,
Got you. Yeah.
but
Look at the recording, if anything.
Yeah.
You know. And then get it. Are you guys done with the board? Can I take it out? Appreciate it. All right, to everybody online, have a good night. See you on Monday.
Take care of this.
All right, see you, man.